have read you the What's Your Angle Pythagoras to kind of introduce you to the Pythagorean Theorem. So this unit is all about the Pythagorean Theorem, which can only be used on right triangles. So you can only use what we're going to be learning about on right triangles. So this stands for 8th grade geometry, and we're doing geometry 6 through 8. So I need you to turn to this page in your packet. And we're going to apply some of the things that Pythagoras found. So first I want you to out to the side label this, or number this, sorry, 1, 2, 3, 4, 5, 6. You also are going to need 2 different colored pencils. So I'm going to use pink and blue because Pythagoras used red and blue. So if you need to pause and go get them, go get some. All right, from there, what I need you to do is come down to box 5 and 6, and we're going to do a 2 by 2 square. And at any point you need to pause this to color it in, then do that. So this square is a 2 by 2, which means there's 4 total squares or tiles. So if this was Pythagoras, he would have made a side that was 2, a length of 2, and our square on that would need 4 tiles. Then from the bottom right corner of that, we're going to do another 2 by 2. So his side lengths on his triangle so far are 2 by 2. You can do different ones. It's just easier this way if we keep our triangles isosceles. So that's why the ones I'm going to show you are going to be isosceles. Then we're going to show where our right triangle would be. So our right triangle, those 2 would be our sides. And straight across. So there's our right triangle. And I'm going to put my right angle there. So now I have my triangle. So what Pythagoras found is that these 4 pink ones and these 4 blue ones, when I add them together, are going to create that big big square right here. So that means that our big square should have 8 total tiles in it. That doesn't mean that my side length is 8, but it should have 8 total tiles in it. So that's what he discovered. So how to do your tiles, what you're going to do on this is you are going to start from the corner here, and we went across 2 tiles, so we're going to go through 2 tiles. And then down through 2 tiles, always through the diagonal. And then 2 tiles, 2 tiles. So now if you look, and I'm just going to color mine. You can do yours a design if you'd like. But we need 4, according to what Pythagoras found, he said that these 4 pink tiles should fit inside here. So I have 2 full tiles right here. And I could keep going and do these 2 full tiles. But I'm going to do this half and this half right here. So that's 3 tiles. And then these 2 halves together are going to create that 4th tile. So 4 pink tiles fit there. 4 pink tiles are going to fit in this big one. Now we have blue. These are going to make up 4 tiles as well. And that's exactly what Pythagoras found, is that when he did this, the number of tiles he made to create this square and the number of tiles he used to create this square gave me the total number of tiles in this big square. So we're going to do, let's try a 3 by 3. So on this one, again, we're going to count down the side. 1, 2, 3, 4, 5, 6. And we're going to start shading at 4, 5, and 6. And we're going to do a 3 by 3. So that means that he would have used 9 tiles to make this square. Now in the book he used a 3, 4, 5, which is a super common side length for a right triangle. So this is a 3 by 3. Then I'm going to take and I'm going to do a 3 by 3 starting here and going down. So what he found is that the 9 squares that it took to make up this, or tiles in this case, and the 9 tiles it took to make up this, tells me that in my big square, I should have a total of 18. So again, here would be my right triangle. So those two side lengths together. And then I'm going to go, since I went through 3 tiles, I'm going to go through right at the diagonal, go through 1, 2, 3. 1, 2, 3. 1, 2, 3. And we can count. I'm going to do 1, 2, 3, 4, 5, 6, 7, 8. I'm going to make a pattern on this one. So I'm going to actually take these off. So I have 1, 2, 3, 4, 5, 6. 9 is so crazy. We just need 9. So 1, 2, 3, 4, 5, 6, 5, 6, 7, 8. And then we'll do that one, 9. Okay, so I'm going to shade those. So there's 9 blue. So there's 2. And that half is 3. There's 4, 5, 6, 7, 8, 9, 2, 4, 6, 8. Oh, I did too many. See, I get all wanting to do a pattern, then I get too many. So let's try this again. We just need 9 total squares. So we will do doesn't like me racing that much. Okay, so I'm just gonna shade, and we'll keep it easy. So I'm just gonna shade. There's 2, 4, 6, 8, and then I'll do this one as 9. And then for pink, I'm going to have 2, 4, 5, 6, 7, 8, 9. So you can see once again, they all fit in there. 9 blue fit, 9 pink fit. So that's what he was discovering, is that all of these together are going to fit inside here. All right, so now let's go into our notes here. So first thing we're going to look at is remembering that this will only work on right triangles. So the Pythagorean theorem only works for right triangles. Only works for right triangles. So right triangle, first of all, you should know that this right here means right angle. And so the two sides that are attached to the right angle, so the ones that are actually touching the right angle, are known as legs. We call them sides, but they're also known as the legs of a triangle. We call them A and B. One's A, one's B, and it does not matter which one's A and which one's B. So if you remember in the book, you had a side length of 3, a side length of 4, and a side length of 5. 3 and 4 would be our legs. So A and B are interchangeable. The side opposite, or across from the right angle, is called our hypotenuse. Hypotenuse, or leg C. This is the one that does matter. So if you find your right angle, the one side that is not touching that right angle is C, which will always be our hypotenuse. Leg C, or your hypotenuse, will always be the longest side. So it has to be the longest side of the right triangle. So we have our formula for this, and if you remember in the book, he said a squared plus b squared equals c squared. That's the formula that he used. So here's what we're going to do. We're going to, step number one, we're going to label the sides A, B, and C. A and B are interchangeable. C has to be the longest side. This has to be the longest side. So C will always be the longest, and it is across from the right angle. It's not ever touching the right angle. Once we've labeled A, B, and C, we're going to plug it in to our equations, our formulas. So let's say that we have a leg that's missing. In this case, what a leg is missing would be like A or B is missing. So they've given you C, the hypotenuse, and one other side. To solve this, we're going to use subtraction. And we're going to take the square root. This is so important that you don't forget this. This is the one thing that I know over and over again when I go to look. This will be the thing that you forgot. Our formula says, take C squared. And you're going to minus, in this case, I'm just going to say A squared. But you can do A, it's A or B. So if you need to write or B squared down there, you can. I'm just going to call it A squared. It does not matter though. I'll show you why this formula works. It's just kind of a shortcut. Pythagoras came up with this one, which is the one you'll know all the time. This one just gives you a little bit of a shortcut. So let's say that like C is missing. So they've given you both your A and B, but you're missing C. And so if a hypotenuse is missing, we are going to add. We're again going to take the square root, and you can put it all under at the same time. And we're going to do A squared plus B squared. All right, so let's look at some of these examples. First thing that we're going to do, step number one, we need to find our right angle. Here's my right angle. So the side that is not touching that is C. That's my hypotenuse and should be my longest one. So I'm going to label this A and this B. Again, you can label it A. This one, you could label this side B and this one A. It doesn't matter, but C has to be the hypotenuse, the one across from it. Once we've done that, step two says plug it in to our equation. And I didn't even finish this word. We're going to solve. That got disappeared from yours, but it should say and solve. So we're going to plug it in and we're going to solve it. So we have both of our legs. We have A and B. So we're going to use this formula. So in your calculator, you're going to hit the square root, and then you're going to hit A squared. So in this case, 15 squared plus 18 squared. And you can do it all at the same time. Let me pull up, see if I can pull up my calculator. Mine's a little bit different than yours, but similar enough that it will work. So let's see here. It's the same calculator. Mine just does a function, one more function. So, all right. So we're going to plug it in. So you're going to hit the second x squared button. So second x squared. It should bring up your radical sign. And then we're going to put A squared, which we said was 15 squared. So again, all this is going under there. Plus I need 18 squared. Now, knowing that my hypotenuse is my longest side, I should know that my number needs to be bigger than 15 and bigger than 18. Because if it's the longest, it has to be bigger than 18. Sometimes it will tell you to leave it in radical form. So you'll notice yours on your calculator is going to come out as 3 radical 61. You need to convert it, use your convert key, and get the decimal. Most of the time, you're going to be rounding to the nearest tenth. So that's the first number after the decimal. So in this case, we're going to get 23.4. And yours actually probably came out on your calc. Well, I don't know. I don't know how it came out. Maybe it came out as radical 549. I'm not sure which way, but so then what we're going to do is we're going to round it to 23.4 and box it off. That means that this side was 23.4. So I look, this should be my longest side. It's longer than this. It's longer than this. So that looks good. Now, if you were to do it and solve it, you'd be doing the same thing because you'd want to get solve for C. So it just takes longer to walk through it, so that's why I'm just giving you the shortcut. Step 1, find our right angle. The number across from it that's not touching our right angle is C. Then you can label whichever one you want, A and B. But C has to be your longest side. In this case, they've given us one leg and the hypotenuse. So again, we're going to use the square root or a radical sign, and it's going to be C squared. Our formula is going to be C squared minus A squared. So then I'm going to plug it in. So instead of C, I'm going to do 10 squared, and then I'm going to minus, instead of A, it's going to be 6 squared. I put it in, and this one's going to come out nice. Well, in your calculator it would be 100, but it's going to simplify everything down to 8 for your final thing. All right, pause here and try to find your right angles on these. If you paused and checked, I'm just going to show you. So I'm going to label your C's. That's what I want you to. And then you need to make sure these are rounded to the nearest tenth. So this should be your C. So again, I'm missing my hypotenuse. So on this one, we're going to set it up as my A squared plus B squared. Right angle, across, not touching, this is my C. So in this one, I now know it's going to be C squared minus A squared. And then on this one, that should have been your C. Set it up. On this one, what is the area of the largest square? This is exactly what we did on the grid paper at the beginning. Because when you look at this, they told you that this, if we were to take this square right here, there are 36 tiles in it. So there's 36 tiles on that one. There's 64 tiles in that one. So how many tiles would Pythagoras, if he were building this, how many tiles should he expect in there? And then number 5, a rectangular pool at the gym measures 25 by 50 meters. How many meters would a person swim if they swam diagonally from corner to corner? So first thing you need to realize is that this is a rectangle. So that means we can assume that this is 25, this is 50. That being said, we know that rectangles, opposite sides are going to be the same. So if this side's 25, it means that this side's 25. If this side's 50, this side's 50. So it says you start swimming right here. And instead of swimming like right along the edge, you actually swim at a diagonal right here. It wants to know, what is this? We also know that these are all right angles. So here's my right angle. That means that this is C. So if we pulled our triangle out, this is 50, this is 25, and now we can find C. And it wants you to, does it tell you to round? No. So you can round it to the nearest whole number if you want, or you can leave it to the nearest tenth. But that is what we will be looking for.